So here we have two different materials. Both of them are painted black. They're both discs. We put ice cubes on them, and we can see easily that this one here doesn't melt the ice at all, and this one here melts it pretty efficiently. And that's basically the experiment to show for 20 seconds. Okay, let's turn on the Bunsen burner. There we go. And I'm going to put a copper rod in here with some paper in it, and as we can see, not as well, but it does burn a little bit, but not as effectively as if I just would put the paper itself in the flame. So you have to explain, well, why doesn't the paper just go up in flames? Totally. Okay. Next one is the ball in the ring, and this one right now barely fits through, but now I can heat up the ring. I'm sorry, what did I say? I can heat up the ball right now. There we go. And that one here, it's a really tight fit. And now I heat up the ring, and at the same time let the ball cool. And I have a pretty good fit. And then if you could give me a bimetallic strip. In the meantime, I can still play with this one. Okay, so here's the bimetallic strip from the freezer, and it bends in one direction. And now I hold it in the flame, and notice that it will start bending in the other direction. Okay. And over here, this one will be really tough to see on the camera if you want to film the thermometer reading, and go a little bit out first. So I have here to show this one here, to show the beaker. So here I have hot water. It's not boiling anymore, but it's hot water. So what I'm going to do is I'm going to put it right under here, and then I'm going to immerse it and watch for the temperature reading right as it goes into the water right now. I don't know, did you actually see that? Okay, so it may show up on the video. Okay, this one over here, in the meantime, that's just for show and tell. There used to be wax on all of these three metals, but it has melted off the wax on the copper. In the meantime, it's still pretty hot, and the wax on the aluminum are gone, and the wax on the steel is still there after we had turned on the heater. Okay, and a couple, three more. These are different metals. That's lead, copper, and I believe that's zinc, and here is aluminum, and they're of different sizes so that they would have the same mass. Obviously the lead with a much higher density has to be much smaller than the aluminum in order to have the same mass. So mass is not a factor here. What is a factor is well, which one holds the heat the most, and we can see that the lead hardly sank in. The tin sank in pretty good actually into the wax, and of course these were heated in water before. And then the aluminum, technically the aluminum should stand as well, but I think we can see that it did go in quite a bit. Okay. I think I have about 2 or 3 more here. So these are the radiation cans. I put hot water in. In fact, it's still pretty warm on both. Oh, this one is actually pretty hot. The silvery can right now reads 58 degrees Celsius, while the black can reads about 48 degrees Celsius. So we can see, and they both started out with the same temperature water. Okay, this one here is just for show and tell. So just a thermos. It's broken, that's why I use it in a lab here, but why does a thermos have a silvery surface inside, and why is there, well, technically a vacuum around the inside? That means that the inside is not the same volume as the outside. And apparently that has to do with keeping the food or the drink warm that you put in the thermos. Okay, I believe I put a couple more over here. So here's the Franklin Palm Glass that I put in one hand. And we can see it bubbling there pretty good on the other side. And now I put it in the other hand. And we also see it bubbling pretty good. Okay. And let's see if this one here still works. Actually have to, plug it in and turn it on. Would help. Okay, let's give it a moment here. Nah. Let me turn it off here. Let me actually remove this. And let's stop and we make another video for this one here.